years ago, a star passed very close to the sun, causing huge tides and eruptions of gaseous materials on the sun's surface. Some of the erupted matter was torn free and began to orbit the sun. When these chunks of matter cooled and condensed, they formed planetesimals. The bigger ones attracted other chunks and grew into planets. The solar system was formed from these major solar eruptions.
In the beginning came the creation. Time, space, matter, and energy were born. The early stars were formed. When their fuel was used up, the ancient stars died, some violently, leaving vast clouds of interstellar gas and dust. One of these clouds lay dark, cold, and silent for a very long time. Then, over 4.5 billion years ago, it began to collapse, perhaps triggered by the explosion of a nearby star. The cloud was pulled inward by its own gravity into a flat, spinning disk. At the center, a star began to form. From the leftover matter, planets were taking shape. Finally, the new star flared into life. The miracle of creation had begun anew. Now, 4.5 billion years later, a new miracle has evolved. Intelligent life, reaching out beyond the planet of its birth. In this golden age of discovery, we have seen worlds of infinite wonder. This is the story of these worlds and the star that rules their lives. This is the story of our amazing solar system.
In the early 1980s, scientists came up with a hypothesis to try and explain a perceived cycle of mass extinctions in the Earth's geological record, which seemed to happen more frequently every 26 million years or so. They came up with an idea that these terrible events might occur because our sun actually has a companion that has been named Nemesis and is responsible for destroying life on Earth. If the Nemesis star does exist, it might be a red dwarf star that scientists speculate could affect the orbit of objects in the far outer solar system and could push life-destroying objects on a collision course with Earth. Although astronomical surveys have failed to find any evidence of a Nemesis star so far, it has been suggested that if it does exist, it could be a brown or a white dwarf star, or a low-mass star only a few times as massive as Jupiter. These types of stars cast dim light, making them difficult to spot, which could mean that the Nemesis star is out there, we just haven't found it yet. The Oort cloud is an extended shell of icy objects that exists in the outermost reaches of the solar system. If the Nemesis star is real, then this comet-hurling monster might travel close to the Oort cloud every 26 million years or so, and push comets inwards towards the centre of the solar system, potentially on a collision course with Earth. However, using powerful infrared telescopes, scientists are able to detect brown dwarfs as cool as 150 Kelvin out to a distance of 10 light years away. But even with this technology, they have not detected the Nemesis star. But locating a potential companion to our sun would be very important for the future of the human race. Because if this menacing star does exist and does send huge comets towards us, we will need to figure out a way of preventing another mass extinction on our planet.
Our solar system is the region of space which falls within the gravitational influence of our Sun. The solar system is thought to have begun forming about 5 billion years ago from a giant spinning cloud of gas and dust. The core of this cloud grew under the influence of gravity and became denser and hotter. As material fell towards the growing core, the cloud increased in speed and flattened into a giant spinning disk. Eventually, the increasing temperature generated enough energy to trigger nuclear fusion. This fusion marked the birth of our Sun. The lighter gas was swept far out into the solar system, leaving heavier, rockier material and metallics with high melting points nearer the Sun. Molten metal and dust particles stuck together to form clusters, which in turn stuck together to form rocks. Mutual gravity caused these rocks to come together, eventually to form planets. In the hot inner regions of the solar system, rocky planets with metal cores were formed. In the colder outer regions, things were different. Further from the Sun, temperatures dropped. Water vapor condensed and turned to ice. This ice, combined with the vast amounts of gas blown away from the Sun, meant there was a lot more material here than in the inner regions. As huge cores of ice and metal grew, the gases swept away at the Sun's birth were attracted through gravity. When the accretion of most of the ice and gas was complete, we were left with the gas giants. The solar system as we know it is around 4.6 billion years old. It's looking pretty good for its age.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.